All right, today we're going to be talking about solving inequalities. So there's some important things that you need to know, symbols, and then also how to graph them on a number line. So first off, we have less than. Now I like to think of this like an L. So that's how I remember it. So less than is an open point, and then it means all the numbers are going to be less than whatever number you're talking about. So I like to think of this as like a little arrow. It matches. And then you have greater than, so you're going the other direction, so that means all the numbers are going to be bigger. It's going to be an open point, and then you're going to go to all sides, all numbers that are bigger than that. Next up, we have less than or equal to. This part, so here's your less than, and then this part right here, equal to, is this part. So it's very important because it includes that point. So it's going to be all the numbers including that point. So it is closed, and then you're going to go that direction. Now greater than or equal to means that it includes that point, but it's going to be all the numbers including that point that are larger. All right, and then at least, I think of it as the minimum. So it's really the maximum. You're going to go up from there. So when it's talking about at least, that means it's not going to go below that. So it's really greater than or equal to. And then at most, it's the smallest. You can't go past that. So it's the maximum, and it's the less than or equal to. All right. So now, a couple little tricks on here. If you keep X on the left side, think of this like an arrow, and that's the direction you're going to go. So this is an open point, and then you're going to go that direction because X is less than 2. So it's all the numbers less than 2. Now, here it is X is greater than or equal to. So since it's got this line here, it's a solid. And since it's, or excuse me, I said it's less than or equal to. So it's going to be all the numbers that are less than or equal to 2, so it does include 2. All right, you're going to try these. This is your turn. And then if the variable is on the right side, you're going to go the opposite direction from the arrow. So here it says 2 is greater than X. So really it means X is going to be less than 2. So it's closed. Oops, that should not be closed. That should be open. There we go. All right. So it's an open point, and it is all the numbers. X is going to be this direction because 2 is the maximum. All right, so you're going to try this one. And remember, you just go the opposite direction, but I always like to try to get the variable on the left, but if not, just go the opposite direction. All right, so now fill this in. So solving inequalities is the same as solving equations, except when you multiply or divide by a negative number, you have to flip the inequality symbol. Very important. All right, so if we were to have 3 is less than 5, and you were to multiply both by a -1, so then that means you're going to get -3 is greater than or equal, or sorry, greater than -5. So that means that we had to flip our signs. So whenever you multiply or divide by a negative, you have to flip. All right, so now let's go ahead, let's start solving our inequalities. So for this, I still like to draw a line. I still like to choose my variable and my constant side. And then I usually try to get the variable on the left, but if not, that's okay. So first, I need to move the 7 over here. So I need to do the opposite. So I'm subtracting 7. That cancels out, and I'm left with 6a. Bring the inequality down, so which means greater than 12. Now we need to get 6 by itself, or excuse me, we have to get a by itself, so we have to move the 6 over here. So that's why we're dividing both sides by 6, because that's 6 times a. That cancels your 6's out, and you have a is greater than 2. Now this is going to be an open point, and you're going to write your number here. So we said right here, and we said that since a is greater than 2, we're going to go that direction because all of these numbers are greater than 2. All right, so now let's look at this one. So again, I like to draw my line down the inequalities, and I'm going to make this one my variable side and that my constant. So I need to move this -4 over here, so I have to add 4 to both sides. Oops, sorry. That cancels out, and I'm left with -3x, and then you have 18 here. So now we need to move the -3 over here, and since this is -3 times x, you have to divide both sides by -3. Now, since we divided by -3, you have to flip your sign. So now your sign is this direction, and 18 divided by -3 is -6. That simplifies to give you positive x. All right, so you could do this way, which is a solid point and going the opposite direction of your arrow, or if you flip your order, you have to flip the sign also so it's still the same. But either way, you're going to graph it, and your graph should look like that. And it is a closed point because of there. All right, so what you're going to do is you're going to try the rest. These are your turn. So go ahead, try the rest, and if you did these correctly, let's see. Oops, there it goes. If you did these correctly, you should have gotten for this one, oops, W is greater than, where we go? So W is greater than or equal to 8. And here you should have gotten T is less than or equal to 5. Here, X is less than -6 over 23, so you're getting a fraction, that's okay. And then here, X is less than 3, if you did those correctly. And graph them. All right, so now we have no solution and infinitely many. It's important not just to look at the numbers, but you want to see if the statement is true or false. So let's look here. Do that. So first we're going to I like to move the variable first. So this is going to be my variable side. That cancels out. I'm left with 2, -3. Uh-oh, my variable canceled out on that side too. So since your variable canceled, since that cancels out, you have to look at your final statement. So your final statement says -3 is less than 2. Well, that is true. So what that means is it's infinitely many solutions is your answer, because the statement is true. It doesn't have to be -3 and -3. Your statement is true. And then now let's look over here. We're going to do the same thing. We're going to solve it. I'm going to move my variable over here. Well, that cancels out here. I'm left with 2, but that cancels out also. So again, my variable canceled. And when my variable cancels, you have to look at the statement. So in this case, this says 3 is less than 2. Well, that's false. So that's not a true statement. So that means no matter what number you put in, it's not going to work. So your answer is no solution. All right, so now let's do this one. So it's saying which are solutions. So you want to know which one makes a true statement is what we're looking for. Okay, so all you got to do is substitute in each value for here after you solved it. So I'm going to try -6. Well, -6 is less than -4, so that's true. All right, because it's a true statement, so it's a solution. So now let's plug this guy in here, and I've got -4 is less than -4. Well, that's not true. So that is false because this does not have the sign underneath there. And then pretty much any number after that is going to be false, but you're going to substitute that into here, and you'll get -3 is less than -4. Well, that's not true. 0 is less than -4, definitely not true. and 4 is less than -4. That's not true either. So your only solution for this set of numbers would be -6. All right, you're going to try this one, and remember to solve for x, then substitute each of your values to see which one's a true statement. All right, now we're going to start translating. So this is a little tricky because sometimes you have to do backwards thinking if it doesn't tell you what sign to use exactly. So when you're doing this, it says write an inequality. So x is at most 30. So when you see at most, that means that's the maximum. You can't go over it. So it has to be less than or equal to 30. All right. For this one, the quotient, well, quotient means to divide, of a number and 6. So a number and 6 is no more than, so it can't go past 15, so it has to be greater than or equal to 15. All right, now your turn. You're going to try these, and for these, just remember when you're talking about product, you're going to multiply of x and y is less than or equal to, so there's your symbol. So that one tells you straight out exactly what it is. So go ahead, write that out, and we'll check our answers. And then here, Carol pays $13.99 for gym membership, and she can take a spinning class for an extra $2.50 per class. Well, this $2.50 per class means you're going to multiply. And if you have a budget of 30, that means you can't go past 30. So which one of these would be the best option? So go ahead, and I want you to complete those. All right, we got some more over here. Oops. Fishing Adventures rent small fishing boats. Each boat holds 8 people. Write an inequality schema to describe the number of people that a boat can hold. Well, a boat can hold anywhere, oops, where'd I go? There it goes. A boat can hold anywhere from 0 to 8 people, but it can't go past 8. So that's your inequality is 0. X is going to be between 0 and 8. And since it can include 0 people and include 8 people, they're solid points, and then you connect them. All right, this one says if 5 times a number is increased by 3, so that's plus 3, the result, that's equal, is, or excuse me, the answer is at least 19. So this is the at least 19. So when you put it all together, this is your inequality, and then you're going to go ahead and solve it. That cancels, and you're left with 5x is greater than or equal to 16. Well, now we need to move the 5, so since you're multiplying, you have to divide. And your answer would be 16 over 5 or 3.2, but we want to find the least possible integer. So integer is your positive or negative whole number, so basically no fractions or decimals. So the smallest integer, well, we can't go to 3 because that would be less than 3.2. So the smallest integer is 4, so you would put x is greater than or equal to 4. All right. For this one, it says a company charges a fee of $6 plus 2 per hour, so you're multiplying. John has 13, so you can't go past $13, but he does have 13. What is the maximum number of whole hours he can rent a bike? So you start off with 6 plus 2 per hour, and you can't go over 13, so it's got to be less than or equal to 13. So we're going to move our variable. That cancels out. And I've got 2x is less than or equal to 7. And then remember, it's 2 times x, so you have to divide both sides by 2. That cancels, and you've got x is less than or equal to 7 halves, or 3.5. But we want the maximum number, so you can't go to 4 because that's more than what it is. So the maximum number would actually be 3 whole hours. All right, and then this one, Lori has $600 in her bank account. She wants to have at least, so that's the minimum, $150 at the end of the semester or the summer. She withdraws, so if you withdraw, you're taking out 17 per week. How many whole weeks can she withdraw the money? So this would be your inequality. Subtract 600. That cancels out, and I'm left with negative 17x is greater than or equal to negative 450. Well, now this is negative 17 times x, so we have to divide both sides by negative 17. And when you do that, you have to flip. And when you flip the sign. So now you're going to get x is less than or equal to 26.47. But it wants to know whole weeks. So we can't go to 27 because that's more than what we have. So whole weeks would be 26 weeks. All right, you're going to try all of these problems. And if you did this correctly, the first one should be 0, so x is between 0 and 900. Then it should go, oops. Hello. All right, so 0 to 900 for this one. And then for this one, it's 1214 cartons. Oh, excuse me, this is 4 gallons. And then this is 1, 2, 1, so 1,214 cartons. All right, so go ahead, do those. And then that is how you solve inequalities.